On Tuesday, we talked about how to figure out what we needed to find on our quadratics. We read word problems. We decided, did we need to find one root, two roots, the y-intercept, a vertex, or an axis of symmetry. So today we're going to look at actually doing that with some word problems and doing the mathematical part. So I've posted this as a PDF in case you wanted to write it in your journal or in case you wanted to print it. This first question is talking about the path of the ball is kicked upwards. We have our equation. H is the height of the ball in meters and T is the time in seconds. So you're going to want to have your calculator available so you can look at this. How high is the ball after 3 seconds? So remember, 3 seconds is T. So we can do this a couple of ways. We can put 3 in place of T in our calculator. So I can go to new calculator document and we can say 35 times 3 minus 5 times 3 squared. And we can see that it is in fact at 60. We could say 60 meters. A second way that we talked about you could do this is you could in your calculator add a graph. And we could then say 35x instead of t minus 5x squared. And we can graph this. We can also use our table feature, and it said, how high would it be at 3? Well, at 3, it is in fact at 60. So that is a second method to check your work. That isn't a root or any of those special vocabulary words. It's just a specific coordinate. So if we wrote this as a coordinate, it would be 3 and 60. When will the ball be 50 meters high or higher? So now we're looking at 50 in place of h. Now, because it says or higher, that's a little trickier to do writing an equation like we did before. So I'm going to go back to our calculator, and you can see here that at 2, we're at 50, then at 3, we're higher, 4, we're higher, and then back at 5, we're back down to 50, because remember, what goes up must come down. So we know at 2 and at 5, we're at exactly 50, and any of the seconds in between, it would be higher than 50. So this is going to be a domain type of question. So we're saying the time that it is at 50 or higher is including 2 and 5 and any of the seconds in between. When will the ball hit the ground? Well, this is going to be a root. So we can do this a couple of ways. So if the ball is on the ground, then we are at 0. And we could go through and we could solve this for 0. Or again, we've got our calculator, we could go through and we can see in fact here 7, we're at 0. We went back up, we could see that we did in fact start at 0, 0 because we don't have a constant on this quadratic, which means that our y-intercept is 0. So we can say here, when will the ball hit the ground? At 7 seconds. At what height was the ball kicked? Well, again, there is no constant on this quadratic equation. So the ball was on the ground. Or we could even say was at 0 meters on the ground. And would that make sense? Well, yes, because typically a ball is on the ground when you kick it. So I'm hoping that makes sense. I want to go through this second one with the archer for you, and then I'm going to have you try this last one. I'll put those answers in a Google form for you to respond to see how you did. An archer shoots an arrow into the air. Here is our equation that describes the path of the arrow. Again, h is height and t is time in seconds. So how high is it after 2 seconds? So again, we can plug in the 2, or we can simply graph it on our calculator. New document, no. And we could say 5 plus 17 times 2 And then we would say minus 5 times 2 squared, and we can see we get 19. So how high was the arrow? It was 19 meters. And again, we can put that equation into our calculator. It was 5 plus 17x minus 5x squared. And then again, if we look at the table for 2 seconds, we are at 19. What is the max height of the arrow? So this is our vertex. So if we wanted to do this, the calculator would be the easiest way. You could do negative b over 2a if you wanted to find that x and then plug it in to find y, which we did a while back. We can also Control T, we can do menu, 6, we're looking for the max, which is 3, and just put your dotted lines on either side. So 1.7 and 19.5 is our coordinate. And so make sure it says what is the height. Well, again, height is our y value, so 19.5 meters. When does it occur? So again, that's going to be here. So at 1.7 seconds. And when will it come back to the ground? So I guess when will it land? So this is going to be a root. So we can, again, we can use our table. And we can see that it is not falling in our table. So this is a situation where we need to do find our root with our menu and make sure you're looking at the second one. So we'll call that 3 2/3 seconds. I'm hoping that makes sense to you. If you have any questions, please send me a note. Again, I'm going to put these 4 questions into a Google Doc or a Google form so that you can go through and tell me how you did. I hope you have a great afternoon.